times sx squared plus sy squared plus sc squared equal to 0， 对不对？好，这最后这个是每一个都有 nx 平方 ny 平方 nz 平方 nx 平方 ny 平方 nz 平方 nx 平方 ny 平方 nz 平方，好，三个平方加在一起，但这三个加在一起是1啊，1，好 ，the sum of the three square of s components equal to 1. So we get this. This is equal to 0. Okay. So if I denote this coefficient as A and denote this coefficient as B and denote this coefficient as C, then we have n to the power of 4 plus b n squared plus c equal to 0, and we can solve for n squared. N squared is equal to this. This. Okay. And in fact, you can verify that 4ac is always smaller or equal to b squared. So this part in the square root will give us a positive number. So, and b is negative, so minus b is positive. So this is the absolute value of b plus minus absolute square minus 4ac over 2a. Okay, so we get two possible n squared. I may denote it as n squared plus n squared minus, plus correspond to this plus, and minus correspond to this minus. And then I take the square root. I take the square root of this. I get n plus and n minus, the two possible reflecting this, which means that we have the double shell structure. Okay. We already know this. Now I want to show you that we can derive an equation to describe the local behavior of the normal surface very close to the K0 point. Remember that we have K equal to n squared, n times omega over c times the s, which means that this is equal to n times omega over c times sx, sy, sc. Okay, so k squared is equal to n squared times omega over c squared. Let me denote this as n squared capital omega squared. Here I define capital omega as omega over c. Okay. Which means that k is n times capital omega times s. And now p n capital omega times nx as x, ny as y, and nz as z. Okay, so we have px equal to n capital omega nx as x, and py equal to n capital omega ny as y, etc. So now I multiply, say, okay, I can write this n to the power of 4 as n squared times this, then times n squared. Okay. Yeah, okay. And then I can multiply the n squared into this factor. And then I multiply the equation by this, by the fourth power of capital omega. So I can treat this as capital squared omega squared times capital omega squared. And 1 capital omega squared gives to this bracket, and the other capital omega squared multiply this n squared. So this part and that part give us k squared p squared. Okay. K squared is equal to n squared times capital omega squared. And the p squared is equal to n squared capital omega squared times nx squared sx squared plus ny squared sy squared plus nz squared sz squared. Okay. Here. So the first term, we get k squared times p squared. And minus n squared times nx squared sx squared times omega squared give us px squared. Px squared. Okay. So we have ny squared plus nz squared times px squared times capital omega squared. So I factor out the capital omega squared times ny squared plus nz squared times px squared plus nz squared plus nx squared times py squared plus nx squared plus ny squared times pc squared. And finally, we have this plus nx squared, ny squared, nz squared times omega to the power of 4. 看看这样对不对？ Okay. Now let's examine the local behavior of this equation at the kz plane, close to the kz plane. So now I want to treat ky different from py different from px and pz. We can collect. Let me rewrite this equation. Kx px minus now I can write this as ny squared times ny squared times px squared plus pz squared. And nz squared px squared plus nx squared pz squared plus nx squared plus ny squared times py squared omega squared plus nx squared ny squared nz squared times the fourth power of omega. 我把它改写成这样。那改写成这样的时候啊，我们去注意到一件事情，这样啊，就是说，我现在想要把 py 或是 ky 跟 px、pz 差别待遇啊，什么意思呢？就是说，我保留，我让这个凡是能够凑成 p 平方跟 py 的，我就尽量去凑啊，这很难解释啊。总之是我推导的一个方法啊。So, what is the sum of px squared and pz squared? This can be written as p squared minus py squared. Okay, so we can replace this part as p squared minus py squared. And this part is even more simpler. Nz squared px squared plus nx squared pz squared. Px squared contains nx squared factor, and pz squared contains nz squared factor. So both of them have this nx squared, nz squared factor. So we can write this as nx squared, nz squared times kx squared plus kz squared. However, kx squared plus kz squared is equal to k squared minus ky squared. Okay. So I can substitute this result into this factor. So what we obtained now is minus ny squared times p squared minus ny squared ky squared. Okay. Py squared is equal to ny squared times ky squared. Okay. And plus nx squared nz squared times k squared minus ky squared. And finally, py squared is equal to ny squared times ky squared. So here we have nx squared plus nz squared times ny squared times ky squared times capital omega squared plus this. So these two terms, we can collect these two terms. Do not forget here we have omega squared. We get k squared minus ny squared omega squared times p squared. Okay. And if we collect this factor and this factor, we get minus nx squared nz squared times k squared minus ny squared omega squared times omega squared. Okay. Then all other terms contain ky squared. We collect them as ny to the power of 4. This times this. And minus nx squared nz squared. No, minus sign times minus sign give us positive sign. Here we have nx squared nz squared give us positive sign. And here we have a minus sign times nx squared plus nz squared times ny squared, which is this. Okay. So now we have this. The common factor kx minus n squared capital omega squared times p squared minus nx squared nz squared capital omega squared. Okay. P squared minus nx squared nz squared capital omega squared plus we can factorize this bracket as ny squared minus nx squared times ny squared minus nz squared times omega squared. Sorry, here we have an omega squared times ky squared equal to 0. So finally, we get the equation of this form. This is the normal surface equation. Okay. Normal surface. It is obvious that if we choose not to write the equation referring to the kx-kt plan, we can still write the equation in another form. Say, for example, we can rewrite this equation as就这两个方程式其实是一样的 ，OK， 但是呢，就是说我们现在是刻意参考 kx-kt plan 去写，好，所以呢会写成这样子。那如果我改成用 k， 比如说我用 ky-kz plan 去写的时候，参考它的时候，我会写成这样，但这两个其实 equivalent. These two expressions are equivalent, but now we use this expression. We know we use this expression. So if ky is equal to 0, then this equation tells us that we get k squared minus ny squared omega over c squared times nx squared p kx squared plus nz squared kz squared minus nx squared nz squared omega over c squared equal to 0. So this is just what we already know. kx squared plus kz squared over ny squared minus omega over c squared times 把它整个除以 kx 平方 kz 平方 kx squared over nz squared plus kz squared plus nx squared minus omega squared over c squared equal to 0. So this is the circle, and this is the ellipse. We have already derived this result previously. Okay. So what we want to study now is what is the local structure of this so-called normal surface close to the Arctic axis. So first of all, we want to know the direction of the Arctic axis. First, we want to know the direction of the Arctic axis. We want to know this direction. Let me denote this angle by theta, and denote this very specific k vector as k0 vector. So k0 x is equal to ny omega over c times sine theta, and k0 here is the direction of kx. This is the direction of kz. K0z is ny omega over c times cosine theta. Here, ny means that the ky, the length of ky is just the radius of the circle. However, the same k0 also belongs to the ellipse. So, if I substitute this k into this equation will also be satisfied. So use this fact, we can find the angle theta. So now I substitute this result into this equation. We find ny squared sine squared theta over nz squared plus cosine squared theta over nx squared minus 1 is equal to 0. Okay. So this means that sine square theta over nz squared plus cosine square theta over nx squared这边写错了，这个应该是这样，这样才对，这样才对。好 ，This is equal to 1 over ny squared. Okay. And 1 can be rewritten as sine squared plus cosine squared. Okay, so according to this result, we find that 1 over nz squared minus 1 over ny squared times sine squared theta is equal to 1 over ny squared minus 1 over nx squared cosine squared theta. Okay, so tangent square theta, which is the ratio between sine square theta and cosine square theta, is equal to 1 over nx squared minus 1 over ny squared divided by 1 over ny squared minus 1 over nz squared. Okay, so this is just nx squared, ny squared minus nx squared, ny squared, nz squared, nz squared minus ny squared. Okay, so this is nz squared over nx squared times nz squared minus ny squared, ny squared minus nx squared. Okay, so finally we find the angle, the tangent of this angle is equal to nz over nx times the square root of ny squared minus nx squared, nz squared minus ny squared. Okay. This gives us the direction of this k0 vector. So from the tangent theta, you can also derive secant theta, because secant squared is equal to 1 plus tangent squared. And from secant you can find the cosine squared. And from cosine squared you can find the sine squared. So finally you can derive sine and cosine. And once you know sine and cosine, you know the k0x and the k0z. Okay. Now we want to explore the local behavior very close to this K0 point. Suppose I change K from K0 to K0 plus alpha. Here, alpha has three components denoted as Xi, eta, and zeta. Okay, and we assume that the length of alpha is much smaller than the length of K0. And corresponding to this small variation of K, we have a small variation of P. P is P0 plus beta. Okay. Here, beta means nx to c, ny eta, and nz zeta. Okay. The three components of P0 is given by nx k0x, ny k0y, and nz k0z. Here we have k0y equal to 0 because we are now on the kx-kz plane. Okay. In fact, ky is just equal to eta or alpha y. Okay. So now we substitute this expression into the original equation. Before doing this, we calculate k squared. K squared is equal to k0 squared plus 2 k0 dot alpha plus alpha squared. Okay. Here alpha squared means the square of Xi and square of eta and square of zeta, all sum all of them. Okay. And P squared is equal to P0 squared plus 2 P0 dot beta plus beta squared. Okay. From this, we also get that the length of beta is much smaller than the length of P0. So, the normal surface equation is this k squared p squared minus k squared minus ny squared omega squared. Here ny squared omega squared is nothing but k0 squared. And the p squared minus nx squared nz squared omega squared. This is nothing but the p0 squared. P0 squared plus ny squared minus nz squared. ny square minus nz square nx nz omega square ky square equal to 0。好，就是那个 ny 平方 omega 平方就是 k 0平方。好，然后那个nz 平方 nx 平方 nz 平方这个东西乘上 omega 平方的，它其实就是什么呢？其实就是p 0平方。这原因是因为在 p 0里面p 0里面其实不含 py 嘛，因为 ky 是0然后你看这个怎么看呢？可以这样看，就是说 k0 square is equal to ny square okay times omega square over c square 这没问题。好，那 p0 square is equal to nx square times k0 k0x square plus ny square nz square times k0z square OK 这边应该怎么说才好？OK， 那晒θ之后，其实就做这个东西其实就等于是这边做到这样比较好。T0 square n 对，这边的话，好，这个有点难直接从这边看出来但是可以算得出来We can derive this result P0 square is equal to nx square nz square times omega square over c square。对，其实没错嘛，因为我们刚刚本来就是令 y 等于0的时候得到的。那所以也没问题所以没问题。但你如果直接从这边看的话，会觉得没有那么容易看到但是从这里其实很容易得到这结果。If you use this result, it is very not so easy to find this result. But if you use this equation set ky equal to 0, then you can get this result automatically. Okay. So according to this, when I do the variation from k0 to k0 plus alpha and p from p0 to p0 from p0 plus beta, and the magnitude of alpha beta are much smaller than the original k and p vectors, then since k squared is equal to k0 squared plus 2k0 dot alpha plus alpha squared. So this means that k squared minus k0 squared is 2k0 dot alpha plus second order term. However, we know that alpha is much smaller than k0. So the second order, the square of alpha is much smaller than k0 squared. So we can ignore the higher order term and approximate the result as k0 dot alpha. And similarly, p squared is equal to p0 squared plus 2p0 dot beta plus beta squared, which can be approximated by, which means that I can approximate the difference between p squared and p0 squared as 2p0 dot beta. Okay, so now we can use this result and remember that ky squared is nothing but eta squared. Okay, so the result is 4 k0 dot alpha times p0 dot beta plus 我再2分钟啊 ny squared minus nx squared ny squared minus nz squared times omega squared times eta squared equal to 0. And to be more specifically, we have 4 k0x times c plus k0z times zeta. And alpha, beta, and p0 both then provide the nx, ny, nz factor. So the inner product will contain the n squared factor. So we have nx squared k0x times c plus nz squared k0z times zeta. There is no eta factor because k0 and p0 do not contain the y component. Okay, so finally we have this. Finally, we have this equation. And in the textbook, this equation is just the equation in the textbook 4.8-6. However, in the textbook, the author forgot this factor, omega over c squared. Okay?好，我们先在这边停一下，好，下课。